Hello, my name is Professor Johnson, and today we will be discussing hypothesis testing and specifically type 1 and type 2 errors. I recommend if you have not watched my previous video, you should watch the video setting up the null and alternative hypotheses. Okay, so basically we get to the point where you set up your null and alternative hypothesis, and then you have to collect evidence by sampling, and we want to make a decision whether we reject the null hypothesis or we do not or fail to reject the null hypothesis. And keep in mind, when you sample from a population, you won't get a perfect answer ever, so it's possible that there's errors that come into play. That's what we call the type 1 and type 2 errors. So right here I say we may never know the truth of the population parameter. So if you're looking into a population and you're trying to find the true average, or maybe you're trying to find the true proportion, you may never actually know the truth, but with sampling you can get pretty close to the actual truth. But you can also always have these errors when you sample. So let's discuss a type 1 error. So a type 1 error, another word for it would be an alpha error. Alpha error is a decision to reject the null hypothesis when the null hypothesis was actually true. So maybe you've collected some data and then you built evidence and you did your tests and you decided that the p-value was really small, so you rejected the null hypothesis. But it was a mistake. If you actually had the true population, which we probably never will have, the true population, the null hypothesis was actually a true statement. Okay, now with a type 2 error, slightly different. We also call a type 2 error a beta error. That's beta, just a big B with a tail on it. This would be the decision to fail to reject the null hypothesis or not to reject, do not reject the null hypothesis, but the null hypothesis was actually false. So it's just slightly different than type 1, but with type 2, it's a decision to fail to reject the null hypothesis when the null hypothesis was actually false. So you ended up with not enough evidence, so you decided do not reject, and really you should have rejected. So you needed more evidence, but your sample just didn't help you out. Okay, if we go to number 1, let's make some kind of sentence. We'll describe the type 1 error for this null hypothesis. So describe the type 1 error if the null hypothesis is this. Doctors at a clinic claim that at least 80% of their patients are satisfied with their quality of healthcare. Now, in my previous video, I have set up HO and HA for you, and I discussed that in the other video, so I would go and watch that if you can. And this would be P, at least, greater or equal to 0.8. And then P would be less than 0.8. And I discussed how to get that in a different video. Now, the type 1 error, as we can see right here, it's the decision to reject the null, reject the HO, but HO was true. So you rejected, but it actually was true. So let's describe the type 1 error. Just write a sentence. So to write a sentence for this, we could say the test concluded to reject HO. So rejecting the HO would be going with less than 80%. So the test concluded that less than 80% of the patients are satisfied with their healthcare quality, right? But truly it was greater than or equal to 80% satisfaction. So as you can see, this is an error. You rejected HO, but really you shouldn't have. But mistakes happen in sampling. That is what's called an alpha error. So let's do a type 2 error. Here we want to describe the type 2 error if the null hypothesis is the tutoring center helps no more than 100 users per day. So HO, so no more than 100 users per day. And because I'm not dealing with proportions, I'll put mu. Mu, no more, so that would be less than or equal to 100. That would tell me that HA would be the contradictory to that, which would be greater than 100. So type 2, just as a reminder, this is the decision to fail to reject the null. So you fail to reject this when the null hypothesis was actually false. So you failed to reject this HO, that no more than 100. You failed to reject that, but it actually was false. So you truly should have had evidence. You were hoping for evidence for HA, but you didn't have enough evidence. So let's write a sentence describing this. So let's say the tutoring center thinks the mean is less than or equal to 100 users per day. But actually, the average, or I'll say the mean was more than 100 users per day. So as you can see, a type 2 error, you failed to reject HO. So you failed to reject this, so the tutoring center or our researchers thought that the mean is less than or equal to 100. But really, it should have been false. So the contradictory or the false statement to the null would have been the alternative, which would have been truly more than 100 users per day. But we just didn't have the evidence in our sampling to show that. That's a description of type 2. Let's do one more example where we will do both. We will both describe the type 1 and the type 2, just all together in the same situation. So in number 3, we are interested in testing if the average number of years it takes community college students to graduate is 2 years. HO would be mu equals 2, HA, mu not equal to 2. Again, I worked this null and alternative in a previous video. Go look for null and alternative hypothesis video. Okay, type 1. This is the decision to reject the null when the null was actually true. So what we're saying here is that the mean is actually 2. Mean is 2. Okay, that's what we want, but we rejected it. So we made a mistake. Let's write a sentence to describe this. So you decide it does not take 2 years on average to graduate, but it really does take 2 years on average. Again, so the decision was to reject the null, but that was actually wrong to do. So if you rejected HO, it left you with the decision, okay, does not take 2 years, but it really was 2 years on average. So that is describing the alpha error or the type 1 error. Okay, now let's describe the type 2 error. This would be the decision to fail to reject the null hypothesis when the null hypothesis was actually false. So now you're thinking differently. HO should have been false. So the mean should have not been 2. Mean is not 2. But you failed to reject that. So you decided that the average is 2 years. You decide that the average is 2 years to graduate, right? When it truly was not. Okay, so again, you failed to reject the null when the null hypothesis was actually a false statement. Thank you for watching.